CRD 4.1, using your factoring skills to work with fractions. I'm not a huge fan of that title because you're basically simplifying fractions in this whole lesson. In fact, all of chapter 4 has to do with algebraic fractions, and it's based on all of the principles that you've learned about fractions before, the ones that you practiced in probably 4th, 5th, 6th, and even 7th grade. Only now it's just getting increasingly more complicated, as you would expect. We're going to basically reach back to the ones we did earlier in this book in chapter 1, or in Jousting Armadillos, we did some algebraic fractions as well. We're going to, obviously, since it's going to increase in difficulty, and we've been working with polynomials and factoring, that gets put into the problems as well, which I will show you, but it's all based on the same principle that you learned way back the first time you learned how to simplify a fraction. So it's a kind of cool connection, actually. The leprechaun has brought you a very fun fraction. Leprechauns always bring good presents, either money, candy, or just general good luck. So hopefully he will do that for you. Taking a look at the one we have here, this is a complete review, and I'm going to do it the long way just to make a point. If I were to write out all of the factors on the top, I would have 5 because 5 is prime. X to the third is going to be x times x times x, and then times y. On the bottom, 10 factors into 2 times 5 times x times x times y times y times y times y. This is the long way to write it out. Then we're basically going to cancel out any factors that are the same on top and bottom, or factors of 1. But before I do that, I want to point out that everything that's in between here, 5 times x times x times x times y, these are all multiplication. Down on the bottom, 2 times 5 times x times x times y times y times y times y, all multiplication. There is no addition or subtraction. In between the two lines is division, and division, as you know, is related to multiplication. But it's important to notice there is no addition or subtraction in either one of these. We're going to learn to work with addition and subtraction, but we have to be careful. It has different rules. So because this is all multiplication and division, I can then factor out 5 divided by 5 is 1. So that's not, if I take that factor out, I'm going to reduce the fraction. There's another 1, there's another 1, there's another 1. What do I have left when I've simplified? I have just x on top, and on the bottom I have 2. Y to the third power. And if I looked at this and did it the faster way, I would have saw 5/10 is the same as 1/2. I could write a 1 here, but I don't need to. So 1/2, and then x to the third over x to the second, you're going to have 1 extra x on the top. Y over y to the fourth, you're going to have y to the third on the bottom. And so that's going to give me my reduced fraction, and that's the answer. Okay, you will start out there in this lesson, but you're going to get increasingly more difficult, which I'll show you. Okay, one thing that is new is this question right here. What values of x or y would make this fraction undefined? Now remember, you can never have a 0 on the denominator. Doesn't matter what number you have in the numerator, you can never have a 0 in the denominator. In fact, it's undefined. It should give you math hives. No, no, no. It's undefined to have a 0 in the denominator. So if I look at my original fraction, and when I ask this question, I do want you to look at the original fraction. What value for x and what value for y would make this denominator turn into a 0? Well, x cannot be 0 and y cannot be 0, because if x was 0, then everything would turn to 0 in the bottom. If y was 0, everything would turn to 0 in the bottom, and we would have an undefined problem. So this is called forbidden values, or that's what Linus calls it. Forbidden values of x and forbidden values of y. I call it restrictions, and I'll use both terms. I think forbidden values is not really a mathematical term, but I could be wrong. Restrictions is the one that I've always seen and used before. So either way, what's going to make the denominator turn into 0? Okay, moving on. So these are going to be more of our new types of fractions that we're going to work with. This killer whale is pointing out how difficult or easy these might be. Simplify the following fractions. Well, look what we've got here. Here I have 6 times, remember how I was talking about times, parenthesis, x minus 4. Because I have a minus in here, this x minus 4 is an entire unit that works together. I'm going to change into a highlighter so I can highlight this unit, this yellow unit. And the minute that you have parentheses, you have created a unit, okay, like something that sticks together. And in between this 12 and the parentheses is time. So I'm multiplying 12 times this yellow unit and 6 times this yellow unit. Both of my yellow units are exactly the same. So therefore, I can cancel those out. Okay, if you look in this one, my units, this yellow unit is actually different from this purple unit because this one says x plus 4 and this one says x minus 4. So those actually cannot cancel out because they are not identical. Okay, I'm going to go back to my 6 and my 12. 6 and 12 can reduce. I've gotten rid of x minus 4 because that's basically just 1. 6 and 12 turn into 1 over 2. So my final reduced answer in this fraction is 1/2. That's my answer. Over here, my x plus 4 and my x minus 4 actually don't cancel out, but my 6 and my 12 do. So what do I have? 1 times that yellow unit, so x plus 4. And I don't need parentheses anymore because it's just 1 times that and nothing else is up there, so I can take the parentheses away. On the bottom, however, I do need to keep the parentheses because the 2 is there. Or if I wanted to, I could distribute the 2 into the parentheses. But that is as simplified as I can get that fraction. If I look at this final question here, the temptation is to cancel out the x's and maybe even cancel out the 4's and get -1. But that is incorrect because this fraction has a plus, this numerator has a plus in it, and this denominator has a minus in it. So again, these are separate units. X plus 4 is 1 unit, and if I put it together using a highlighter, you'll see these go together. And then this x minus 4, this stays together, and they are not the same, so I cannot cancel them. So this is as simplified as it will get. No matter what I do, this is already simplified. Okay? Already simplified. So that is how we do these questions. And I'm going to show you some more examples in a moment that are a little bit more complicated, and I think you'll get into the groove of it. But it's got to have multiplication in between it for it to cancel. Okay, now the next question. What values of x would make these fractions undefined? Well, again, I have to look at the original fraction. I have 6 times x minus 4. Let's see. I think I'm going to erase it. If I have 6 times x minus 4, I'm going to erase everything because now we're looking at the forbidden values. And I have to go back to my original equation. What's going to make the denominator turn into 0? Well, this is never going to be 0. This could be 0, though. And if I have 12 times that 0, it would force the denominator to be 0. So in this case, the restricted value or the forbidden value is that x cannot equal 4. So the answer to this question is 1/2 is the simplified version, but x cannot equal 4. Both are part of my answer. The answer for this one, remember, was x plus 4 over 2 times x minus 4. But looking here, the only thing that is going to cause this denominator to go to 0 is that x cannot equal to 4, same as the one before. And then here, remember it was already simplified, and the only value that's going to cause the denominator to turn into 0 is that x cannot equal 4. Well, there you go, they all are the same thing. So now we're going to look at the next one, which is not going to have the same answer for anything. The next slide. It says, use your factoring skills and simplify the following fractions as much as possible. State any forbidden values or restrictions. Okay, so if I take a look at my first question, I've got 2x plus 6 over 3x plus 9. I cannot cancel anything. It feels like I can. It feels like I could cancel the x. It feels like I could reduce the 6/9. But because I have a plus here, this is a whole unit. 2x plus 6 is a whole unit, and it all goes together. 3x plus 9 is a whole unit, and it all goes together. And I can't cancel it unless it's exactly the same. But I can factor it. That's something I can do. So that's what I'm going to do. I'm going to factor the top. So let's think about this. What can I do to factor it? It's not even a quadratic. The only thing I can do to factor it is use a GCF. I can pull a 2 out, and then I've got x plus 3 left. Okay, on the bottom, what can I do? I can pull a 3 out. What do I have left? X plus 3. Ooh, do you see it? 2/3 won't cancel, but I have an x plus 3 on top and an x plus 3 on bottom. They're both in parentheses, and the parentheses are identical. So I can cancel this set of parentheses and this set of parentheses, because that essentially is like canceling out a 1. So what is this fraction when it's all the way reduced? 2/3. And that's it. Okay, what are my forbidden values? Remember, I got to go back to the beginning of the question to tell you what x cannot equal. So I could either say, all right, 3x plus 9 equals 0. What's going to give me x cannot equal negative 3? If I solve that, I would get that as my answer. Okay, I could also look at the factored version. The factored version was 3 times x plus 3 before it canceled out. And I can see it more without mental math, really. The 3 is not 0, but if I had a negative 3 here, that would cause the parentheses to be 0, which would cause the whole denominator to be 0. So therefore, x cannot equal negative 3. So that's my final answer. Okay, next question. I'm going to start by looking at this. I really want to cancel the x squared, but I can't because this is an entire unit until I factor it. This is an entire unit, and unless those say exactly the same thing, I cannot cancel them. So what can I do? I can factor it. So I'm going to factor the top, and I'm going to factor the bottom. So I have an x, and I need to make 21. I know 7 and 3 make 21, and if I make 7 negative and 3 positive, I'll get a negative 4x. Okay, now let's do the bottom, x and x. I need to make a 15, 5 and 3. Those guys will add and give me 8, but they will multiply and give me 15. So I've successfully factored the top, and I successfully factored the bottom. Now, where's my multiplication sign? It's right here. It's right here. Okay, so now I'm going to use that highlighter so you see it. This is 1 unit. This is 1 unit. This is 1 unit. This is 1 unit. I can only cancel out units that are exactly the same, and I see some that are exactly the same. I see x plus 3 and x plus 3. So those can cancel out. X minus 7 and x plus 5 don't cancel out because they're not the same. And they can't be separated. You can't cancel out the x because remember, the x minus 7 has to stay together. So my final answer is x minus 7 over x plus 5. That's my final answer. Okay, now what are my restrictions? X cannot equal what two values? Well, I could look right here and see if I can figure it out, but that's kind of hard. So I'm going to look at the factored form of that and see if I can see my answer there. What would cause this denominator to turn into 0? Well, x couldn't be negative 5 and x couldn't be negative 3 because both of those would turn each one into 0 and then I'd have a 0 in the denominator. So my restrictions are x cannot equal negative 5 and x cannot equal negative 3. And I'm done. Okay, moving along. Same. I take a look at what I've got and I see this is not the same unit as this. I do see some similarities, but I don't see the exact same thing. I've got 3x squared and I've got 8, but my middle term is different and my signs are different and I keep marking it up. So I can't cancel it unless I try and factor it and see if any of the factors are the same. So I'm going to try and factor it. This looks tricky to factor. Are there any GCFs? No, because if I had a GCF, that would make things a little bit easier. So I know I'm going to have a 3x and an x, and I'm going to puzzle around with the 8. It's either going to be 8 and 1 or 4 and 2. I think I'm going to try 4 and 2. And I'm thinking about it, and I am going to go faster than you probably will, just to honor the fact that I don't want the video to be too long. I'm pretty sure this is what I'm going to get. I get on my outers, I get 12x, and on my inners, I get 2x, and 12x and 2x give me 14x. So I factored the top successfully. The bottom also has a 3x and an x, and I need to get 8 again, but it needs to be a negative 8. Again, if I had the same exact thing, only with negative 12x and positive 2x, now I'm going to get negative 10x in my middle term. Okay, so again, the factoring might take you a little bit longer, and that's okay, but just know that I'm trying to go in honor of your time in this video. I'm trying to move quickly. So now I look at what I've got. Are any of my parentheses saying the exact same thing? And they are. 3x plus 2 and 3x plus 2 say the exact same thing, so those cancel out. X plus 4 and x minus 4, as we learned in the last slide, are not the same, and they don't cancel. So that's my answer. That's my simplified version. Feels very tempting to cross out that x and that 4, but you can't do it. They have to stay together because of the plus and the minus. Okay, what are my restricted values? Well, let's look at the factored form. I know x cannot equal 4. I see that one very easily. This one's a little harder to see. So I go over and I do a little scratch work over here. 3x plus 2 cannot equal 0. And I solve, and I get 3x equals negative 2. And I divide by 3, and I get x cannot equal negative 2/3. So x cannot equal 4, and x cannot equal negative 2/3. Those are my forbidden values. Okay, so that's simplifying fractions. I used questions directly from the problem set. So you should be able to come back to this video if you get stuck, but I definitely think take your time in simplifying these fractions and in checking your work, because this is a very easy chapter, lesson to make mistakes on. And I want you to get as many as you can right. Good luck.